Alright, hey guys, so today I'm going to help you find the derivative of a function using the definition of the derivative. Remember that the definition of the derivative is a limit. So it's going to be the limit as h approaches 0 of f of x plus h minus f of x all divided by h. This is the definition of the derivative. It's a nice limit. So let's get started. Here's my function, x squared over 3. Notice that it has a 3 in the denominator, and I personally don't really like working with fractions, so I'm gonna try to manipulate our function so that I only have to calculate the derivative of the x squared. So in order to do that, I just have to simply pull out the 1/3 out in front of the x squared, like this. So we'll have 1/3 times x squared. And recall that one of our rules in calculus is that if we have the derivative with respect to x of a constant times a function, which is what we have here, 1/3 is our constant and x squared is our function, this is equal to the constant times the derivative with respect to x of the function. So I'm going to put 1/3 out in front of the derivative of our limit. So I'm going to put 1/3 in front of our limit, calculate the limit that way. So remember, c is equal to 1/3, so we're going to have 1/3 times the limit as h approaches 0 of f of x plus h. So f of x plus h simply means we're going to plug in x plus h wherever we have an x. So we have an x squared, so I'm going to plug in x plus h into x squared. So we have x squared, x plus h squared minus our function, which is simply x squared all divided by h. Alright, so the next step is to expand our first term, which is our x plus h term. In order to do that, we just simply have to multiply it by itself twice, because that's what it means to square something. So we're going to have x plus h times x plus h. Now in order to expand this or simplify this, we're going to multiply each term here by each term here. So I'm going to take our x, multiply by x, and then take the x, I'm going to multiply by h. So I have x times x is x squared. And then we have x times h, which is simply xh. And then we have h here. We multiply this by x, which is xh. Then we have h times h, which is simply h squared, because we're multiplying by itself twice. So simplifying this a little bit further, we have x squared, we have x plus h, and x plus h. These are two terms, they're equivalent, so we can simplify them by putting a 2 in front of the xh, since there's two of them. Then we have plus h squared. So there you go, x plus h squared is equal to x squared plus 2xh plus h squared. And I'm going to plug in this into my x plus h squared here. So we have 1/3 times the limit as h goes to 0 of x squared plus 2xh plus h squared all divided by h. So let me give myself some more room here. And don't forget to subtract by x squared. You always have to bring down your function f of x, which is x squared. So then we continue simplifying by combining our like terms. So we have an x squared here and an x squared here. X squared minus x squared is 0, since they represent the same quantity and their difference is 0, so this cancels out. And then we're left with 2xh plus h squared over h. So bring everything along, 1/3 times the limit as h goes to 0 of 2xh plus h squared divided by h. So we're almost done. So our next step would be to divide both of these terms by h. So we have h squared here and we have h here. To simplify this, we just have to subtract these two exponents. 2 minus 1 is 1, so we're going to be left with h to the first. And then we have 2xh divided by h. You simply cancel these h's since there's only one of them. And you're left with 2x plus h. And then you have to bring your 1/3 times the limit as h goes to 0. Now that we got rid of our fraction bar, we can simply plug in 0 for h. And then we have 1/3 times 2x plus 0. 2x plus 0 is simply 2x because adding 0 to anything doesn't change it. And then we have 1/3 times 2x. And then our final answer would be 2x over 3. And that is our derivative. Thanks for watching.